right. Thanks for being here early at 8:15 to talk about technology, your diehards. Appreciate you being here. My name is Mark Tatum. I'm the VP of Mission Cloud Technology at Oracle. And I'm here this morning to talk about COOP and what COOP means in cloud world, hybrid world, and the edge world, and kind of what's going on in this space, and how do we provide continuity of operations in kind of a hybrid distributed environment. There's a lot of R&D and investments going on in the cloud provider community. And so I thought I'd share some insights with you so you kind of see where things are going and give you some ideas of how to prepare for this. So the interesting thing that Gartner just published is their prediction is by 2025, 50% of the enterprise managed data will be created and processed outside of large cloud regions. Now, as a cloud provider, that doesn't sound very good to me. I wish it were 20%. But the truth of the matter is 50%, and this is a commercial assessment by Gartner, not an assessment of DoD or the intelligence community or the national security community. This is true everywhere. There's a lot of computing still happening on-premise outside of large cloud regions, and there's a reason for why that is. One is pure economics. There are still economic decisions being made based on legacy systems, things that are going on where corporations and enterprises have decided to keep things on-prem just from a pure economic perspective. That still goes on. And cloud may be more convenient, but is not always cheaper. And if money is an issue, which it is with a lot of commercial companies, they make purely financial decisions on where they're running their workloads. But that doesn't get around the need for COOP. And so that throws kind of a monkey wrench into things. The other thing is egress fees. Not all cloud providers are the same when it comes to egress fees, and those have traditionally been an issue. Oracle is trying to take that particular issue off the table with respect to clouds. So our national security regions, our secret and top secret SCI regions, have no egress fees. So we don't charge egress fees in our classified gov regions. And of course, refactoring costs that go with moving something to the cloud, particularly for a legacy system, is kind of in play. So those are some of the things driving the hybrid, the on-prem side of hybrid. But then you have data sovereignty issues. And this is actually a big deal. It's kind of a trend around the world. And the trend kind of goes like this. If I'm a small country and I'm like, let's see, if I pass a law that none of my business and citizen data can ever live outside of my country boundary, that will require cloud companies to build cloud regions in my country to provide cloud services for the businesses in my country. That sounds like a financial gain for an easy little law that citizens will agree with. So what you're finding now is what Oracle calls sovereign clouds. It's a cloud that has to be sovereign within a country, okay, which requires us to build more data centers and put in more cloud regions. Okay, good for the country. Is it good for us to be seen? But Oracle right now, so I'll talk a little bit about how rapidly and how small we can make a hyperscale cloud region. That's very unique for us. So we're getting a lot of this sovereign cloud business right now. And we're up to 71 worldwide data centers That's way more than any other cloud provider, and a lot of it has to do with these sovereign regions. They use the legal law structure to force this hybrid nature. And then there's just what's happening in the mission that's driving hybrid on-prem and everything. And that is that processing needs to occur where data is collected, where local decisions need to be made, and that can't be done in a hyperscale region in Ashburn, Virginia. If you're sitting out in Dubai, it just doesn't work. There's latency issues and all those things. So if data's being collected, needs to be processed, needs to be decided in Dubai, you don't do the processing in Ashburn. Okay, so it's driving things out to the edge or regionally, and that's what's driving this hybrid computing environment. So if you want to be really like with it in the times, hybrid is dead. We don't use that term anymore in industry. It's now called distributed cloud computing. So if you want to be like, oh, the new term is distributed cloud computing. So that's the new buzzword. So let's talk about COOP, because that's what we're here today to talk about. Is if you're in this distributed cloud computing hybrid environment where you have large cloud regions, you have on-prem, you have hybrid, you have sovereign clouds, how do you COOP all of that? Okay, and that's where a lot of investment is going on. So it's super simple, obviously, if you're in a cloud region. Okay, so for instance, if you're in Oracle's hyperscale cloud region in Virginia, within a cloud region, there are what's called fault domains. So if you're familiar with how cloud regions are built, there's fault domains even inside of a data hall. And what that means is there's separate sections of the data hall that are on different power distribution networks. So if one fault domain goes down, but the whole data center has power, the region didn't go down, there's other fault domains. So you can take a workload and say, I want my workload split across fault domain 1 and 2, fault domain 1 goes down, your workload's still up in fault domain 2. That's just high availability within a region. That's not COOP. Okay, so COOP is, I have a copy of what I'm doing in a totally different region. So for example, we have another region in Arizona. So if you were going to COOP your Virginia, you go to Arizona or you'd go to Chicago. We have another one in Chicago. So those are 3 different areas you can COOP, 3 different things, okay? That's true. We have multiple regions, true for either secret, top secret, IL5, FedRAMP, and Gov regions and commercial. So that's pretty common practice. That's kind of a no-brainer. But then you get to a situation where you're like, should I COOP between 2 cloud providers? We're starting to see that happen, where people are like, well, what if AWS goes down? Like all their regions go down. Has that ever happened? Yes. Well, what happens if I'm not COOPed to Azure or Oracle or Google, for that matter? So that you get into a situation where you're like, I may, depending on the criticality of the system I have, I may want to COOP across 2 cloud providers, and that's totally doable. One of the things in this, people ask me, well, you know, if I'm using Oracle Cloud and I wanted to COOP to another cloud provider, which one would you suggest? Right now, I would suggest Microsoft Azure, and the reason is Oracle and Microsoft have a corporate agreement that when our data centers are near each other, okay, we provide dark fiber between the data centers, so a private network to connect them up. So your 2 tenancies never go back over wide area networks to get to each other. They actually talk building to building, which is kind of cool, okay? So, so anywhere that they're in, so Ashburn's a good example. If I stood on the roof of our building, our region in Ashburn, I could throw a rock and hit Azure's building, but you could hit about every, if you've been to Ashburn, you can hit about every data center by throwing a rock. So, but they're really close, so we put in dark fiber and connect the regions together, and that's an agreement Microsoft and Oracle have made. And that's starting to become more popular. I think you're going to see Google connecting their regions up like that, and I think eventually you'll see AWS do the same thing. So then you get to this situation where, okay, so I'm on-prem. I can't tell you how many mission programs I've talked to mission managers, and I'm like, so this system sounds really important for the mission. Yeah. You have a COOP for it? No. So if your system goes down, you're down. Yeah. I'm like, and there's no COOP? No. How long have you been operating that way? A decade. You know, you're like, okay. A bank would not tolerate that. Okay, a bank would not tolerate that. There were 2 banks at 9/11 that were on Oracle running when the towers went down. They had COOP backups of those banks in New Jersey. They didn't lose one transaction. And that's just a bank. And some of these mission programs have no COOP. It makes no sense to me. So how do you COOP on-prem? Well, you can obviously on-prem to on-prem. But one of the things we're seeing is even with workloads that don't belong, maybe aren't destined to move to the cloud, is there a way we can COOP it in the cloud in some way so we have a COOP for it? And I'll talk about how that can be done kind of painlessly here in another slide. So then you get to this distributed cloud where, okay, we're in a cloud region, but now we're regionally somewhere. So we're in an AOR, okay, which what I'll call near edge. The far edge is kind of the pointy end of the stick. Near edge is you're getting close, but you're not way out at the pointy end of the stick. So you have near edge cloud offerings, I'll talk about that, and then you get all the way out to the cloud edge, tactical or the far edge. And you can COOP those. The investment that the cloud providers are making is COOPing near edge to near edge. So for instance, putting a near edge cloud capability in the Middle East and having a COOP of it in Europe instead of somewhere in CONUS. Right? Or having a far edge capability way out of the pointy end of the stick in a fob, and a COOP of it is the next closest fob. Okay, and so we're creating environments to allow COOP to occur in those areas. So here's a few recommendations to make COOP easier. Containerize your applications, that's kind of a no-brainer. And when you make your applications, do not use proprietary cloud functions. And that's coming from a cloud engineer at Oracle. Cloud providers are notorious for creating cloud functions that software developers love to call in their code. As soon as you do that, you've locked your application into that one cloud provider. It won't work anywhere else. Okay. To get around that, Oracle open sourced a project that they gave to the CNCF, which is the Cloud Native Compute Foundation, which is where the multi-cloud world is going with respect to standards. And it's called the FN project, FN for function. And it is portable open source functions. So a software developer can write a function. It's kind of wrapping a function like a little mini container is the best way to describe what the FN project is. And it makes it portable. So in Oracle, we only run FN functions. So if you write a function in FN, it'll run in AWS, it'll run in Azure, it'll run in Google, and it'll run in Oracle. If you call a Lambda function in another cloud, it will only ever run in a cloud that runs Lambda. So that's just a little bit of COOP things that you have to think about. Obviously, Terraform's your friend. It allows you to quickly script out your COOP environment in your cloud. So you can and everybody uses Terraform. So if you're using a cloud as a COOP backup for an on-prem system, script out everything you need in your environment and in Terraform, and that'll be reusable across all of us. Okay, Here's another no-brainer. If you do not have a COOP capability for your on-prem VMware environments, the no-brainer is let a cloud do that for you. We all have VMware services that you can have COOP workloads of your on-prem VMware in the cloud. So if you're down on-prem, you just switch over, all your VMwares or images are all there running in the cloud, okay? So this is where we get to the next one. Some clouds, so most everybody is familiar with, oh, I'll spin up VMs in the cloud. I'll get VMs, I'll get VMs. I'll get virtual host. We all have bare metal services. They're not all the same. And we've designed ours, and I'll talk about how we've designed ours very differently. But this is a big thing. So if you're running a legacy system, and it's like, yeah, we're running a legacy system. It has its own special operating system. It's on this version. I need to COOP it. You can actually lift that whole bare metal system, move it to the cloud for COOP with its old antiquated OS that you've patched or whatever, and run it on the bare metal there, unchanged, unmodified. Okay, and you get full access to the bare metal node. So it's kind of a true lift and shift. And so I'll talk about how we do that. I talked about the egress fees. When you're doing COOP, many people forget database replication. They think, oh, I have to take the application and make a copy of it somewhere else. That's the easy part. You're like, oh, that application might have a database. Well, you have to replicate the database. And what that means is it has to be up to date. So you have to keep a database in sync in your COOP environment with what's happening in your live environment. So you have to worry about database replication. So you need, the recommendation there is to find something that can run anywhere, that can do master to master, that sort of thing. There's several products out there. Oracle's product's called Golden Gate. It will COOP any database, Oracle, non-Oracle. It'll do master to master, master slave. It'll survive outages. It'll survive through DDoS. It's self-healing transactions, all of those things. But you have to worry about database transactions and replication in COOP. Don't forget that. That's harder than the app part of it. So you have to pay attention to that. So let's talk about this bare metal. So in generation 1 clouds, probably what you're familiar with on the bottom left is you have this cloud host, and all the tenants are carving up those CPUs on that host, okay? And in many cases, they're oversubscribing. You get 8 cores, you get 4 cores, you get 3 cores, you get, and it's a 40-core box, and they've given out 60 cores, okay? Because their hope is, nobody will be running all at the same time. They'll get what they're paying for, okay? But I don't want to call it the dirty little secret, but what is also on that host is the cloud provider. The cloud provider's on that host. They're providing network virtualization, cloud operations, VLAN control, hypervisor control, and they're eating CPUs that you're eating, and they're also on the same host. So if for some way you can hack out of your hypervisor, you are on the host next to the applications that the cloud provider has on the same host, which is a vulnerability. Oracle Cloud is not built this way. What we did was we took all of our hypervisor VLAN control off of the host, and it is off channel and out of band, connected to a special card on the hardware server, to a special off-band computer that is providing the virtualization services, and workloads can't get to it, and it provides that privacy that tenants on those hosts need. And we're not eating into processing capacity that the tenants need for their applications. So the interesting thing here is in our clouds, every hardware compute node is inherently bare metal. What that means is off channel, we're controlling a bare metal node, okay, controlling its virtual network. But if you come in and say, I want a bare metal node, you get the whole thing. We're not on the bare metal node at all, which is how you can lift and shift these bare metal applications straight to bare metal and install your own OS, the whole thing. When you're done using it, we'll wipe it and put it back in service. At any given time, if somebody's saying, oh, I want a virtual host, I don't want the whole bare metal, we will take, our control plane will take bare metal nodes and carve them up and create a virtualized environment for you. So a compute node for us at any given time, next week a node might be pure bare metal for a customer. 3 weeks from now, that might have been returned and we're carving it up for virtualized hosts for customers. But in every case, the virtualization is all out of band, okay? So that really helps with COOP for legacy systems, where they're like, I need to move this somewhere without refactoring, and I want to go bare metal to bare metal. I want to either bring my own virtualization, bring my own OS, and just land it in another bare metal location for COOP. Now, one of the interesting things is our VMware service is all bare metal. So that's very unique in that when we set up a VMware environment to VMware your COOP your VMware, we set up bare metal nodes and install bare metal natively. It's not a managed service per se, where we're kind of your VMware administrator. And VMware admins don't like that. So if your on-prem VMware shop has runbooks, they have a certain version of VMware, they have scripts, everything for their running their on-prem. In our cloud service, we just set up bare metal nodes and put VMware on it, and you can literally do live migrations back and forth. VMware doesn't even know that it's using a VMware environment that's in a cloud. It sees it like it's an on-prem VMware somewhere in another building, but it's actually in an Oracle cloud region. So this is very popular for us right now because we're seeing a lot of VMware environments that have no COOP. And this is like the easy button. They can literally set it up and hit live migrate, make a backup, and it all moves. We've done demos of that where we've set it up in less than an hour for customers and live migrated a workload in VMware. And so that's a good way to go from a VMware COOP perspective. So now let's talk about this distributed cloud getting into DDIL, this near edge, far edge. Why is that happening? There's a couple of things. We talked about this compute and decision-making need to be done at the edge, but what is happening is cloud developers don't work at the edge. They work in CONUS mostly, and they're building these cloud-native applications in large regions, and they need to get those applications to run all the way out at the edge. So they have to build once, run anywhere, and that's what the cloud providers are trying to do, is create this environment where you create a cloud application and it will run all the way out to the cloud edge. The other thing is this challenge of, well, we'll just say you're out at the edge, just get a laptop and really good comms and talk to my app back in Ashburn. And you're like, yeah, really good comms doesn't really happen for me. We're operating in a DDIL environment where we may have no comms, we have comm outages. So saying opening up a laptop and hitting a URL to get to an application is not always conducive. And so these distributed cloud capabilities have to run in an environment where there's no comms whatsoever for long periods of time. So how do we do that? And all the cloud companies have solutions for this. Okay. Then you get down to the tactical edge, and what's happening down there is they're wanting to do AI and inferencing and decision making and predictions all the way down at the tactical edge. Let me give you a good example of that. So when the Air Force flies, a mission, they land, what do? They take the computer out of the aircraft and they get all of the telemetry off of all the sensors, and then they load it in and they start to look at, for maintenance, what's going on with this thing? Do we get any alerts? Do we get any of this? If that data has to come off that aircraft, go all the way back to a CONUS cloud region into some analysis system to do prediction of outages, right? And then the answer comes back, that's not timely enough. That decision needs to be made right out where the aircraft landed. So there's AI systems now being built, digital twins, to do maintenance, repair, and overhaul prediction. Like, hey, based on telemetry I'm seeing, based on a healthy Pratt & Whitney engine, this particular sensor's telling me that has 50 hours of flight time left. You should probably change it now. Okay. And so that has to happen locally. So that's an edge kind of workload, and AI's involved. So that's driving that as well. So this is our portfolio, but it's not unlike what the other cloud providers are doing. And so I'll just share what ours are, but AWS has similar solutions in these areas. But you have your big global cloud regions, and then you have these sovereign dedicated regions I talked about earlier. I'll talk about that in more detail. Then you have what I'll call multi-rack, kind of in the 1 to 3 rack size range. That's kind of the near cloud thing. It needs more power, obviously, a place to run, that sort of thing. And it has a lot more capacity and work, service offerings and things like that. And then you get to the tactical edge where you get really small, right? So if you go all the way to the right, these are little battery powered human packable devices. Then you get to something that's a little beefier, sitting on a table, that sort of thing. And then I'll talk about the station later, but even cloud providers are providing as a cloud service data center, modular, portable, small data center services to take cloud capability out to the edge. The important thing here is workload compatibility. So build once, run anywhere, and sync data anywhere between any of those things. And that's important for COOP as well. So we'll get to, let's talk about these disconnected sovereign regions. So one of the things we've had to focus on because of this sovereign region thing that's going on around the world is we have to be able to make hyperscale regions quickly and small. So we have our control plane for Oracle Cloud down to 12 racks. Okay, so you think of a hyperscale region, okay, like Ashburn, you drive by Ashburn, you see these big data halls. One row in rows is just the control plane. What that means is that's our code managing the whole region, the services, the billing, the virtual networking, the monitoring, right? All of the cyber protections going on. That's running on 12 racks of equipment. Everything after the 12 is capacity for customer workloads. Okay, that's incredibly small in the cloud industry to be that small. Okay, we're trying to get that down even smaller. So we think we'll get to 7 or 8, but we're at 12 right now. So what that means is in a dedicated region, if a customer says, I have room for 4 rows, for example, for a data center region, we can put a dedicated sovereign region in your location. We need 12 racks or 1 row for our control plane, and the rest will be capacity. And if you want that capacity to be a bunch of GPUs, that's what we'll install. If you want it to be mostly storage, we'll put mostly storage. If you want it to be a nice mix, we'll put a nice mix. But that's how we can make so many regions so quickly, is we don't need a very big space. And you can provide us the space, and it'll go in even faster if you provide us a space and we don't have to find it ourselves or build it. So this has proven to be very popular. And these can be disconnected, meaning they don't have to be on the internet. They can be in DDoS environments. They can be on private networks. They can be totally disconnected. Okay. So what does that mean for COOP? Well, what that means is if I'm operating in big CONUS regions, you can get from us regional regions within theater and set up 2 of those, and those can COOP each other. So if you get wide area outages all the way back to CONUS, you're still up and running with hyperscale cloud regions. And these regions have all the services of the major regions. They'll just have less capacity. If you have a lot of room, we'll put in more capacity. If you have less room, we'll put in less. But the services don't change. They're all the same services that you get in a larger region. So that's a big from a COOP perspective. So now that so that's a bigger dedicated region. When you get to these near edge and far edge kind of offerings, you get to kind of larger edge installations and ruggedized installations. The larger one we call Cloud at Customer. It's a rack size kind of solution. It's 1 to 3 racks. It's multi-tenant. It can have up to 2,200 cores and up to 3.4 petabytes of storage. And there's even an Exadata database offering for high performance databases, but these are for larger environments that can handle a data center rack, at least 3 of them, 1 to 3 of them. It can get as small as a quarter rack and up to 3. But that is kind of a beefier environment. And then you get out to the tactical edge devices, and they're smaller, portable. They're listed here. So those can COOP each other, the little ones. They can also COOP with the Cloud at Customer, so near kind of far edge to near edge. And you can also set up a COOP capability with 2 Cloud at Customers in 2 different locations. So we've built in the concept that customers are going to need COOP even out at the edge. And so these all can COOP each other. So then we get into a situation where customers are like, okay, so I'm operating out at the edge and I want to bring cloud with me, so I'm not buying hardware, assembling my own on-prem hardware, even at the edge, particularly to run cloud applications. But I have no data center services at all. I'm in a situation where I got a comm closet and that's about it. I need more than that. So you can actually get cloud center, data center services from the clouds now. So AWS is doing this, Microsoft's doing this, we're doing this. Ours is called the Roving Edge Station. It's a modular data center. If you want to see one, I tried to convince Oracle to bring it here and set it up, but it's in Reston. You can come see it. You can schedule with me after this. You can come to Reston and see it. But it's a full data center. It's like a no kidding data center. There's full HVAC. There's fire suppression, lightning suppression. There's full UPS that will run the whole environment for 2 hours without power. It has redundant shore and generator power. It'll run off a standard 30 kilowatt DoD generator. It's less than 33,000 pounds, so the whole device can be transported on all modes of military transport aircraft. It's EMI shielded. It has all the security cameras, biometric alarms, the whole thing. So it is an environment to run, Cloud at Customer, edge devices, your own hardware. It's kind of a blank canvas. It's a data center. We don't tell you what to put in it. But it is a cloud service. So the same tenancies and things you're doing, it's all OpEx dollars. It's not a capital expense. So we're starting to do this now. I just was talking to a mining company in Brazil they have an edge problem. They're collecting all kinds of data, geological data, at their mining sites. They have 51 of them, and they want to do AI and inferencing right there at the mine site. And they're like, we don't have a data center at the mine site. We don't even have we have a generator. We don't even have power at the mine site. We have a generator. And so they're looking at this. The plan is to start to roll these out to those mines there. So again, this is not just a deal, this is a commercial offering. And we're starting to see commercial companies even do this. Another group that's interested in this is the English Premier League. If you've ever watched the English Premier League, you'll see powered by Oracle Cloud there. All the statistics that are happening in game are all collected and put in Oracle Cloud. And then they make predictions and they do all kinds of analysis for the teams in the stadium. And so they're thinking about putting one of these at each English Premier League stadium. So they have a data center to do all the analytics locally. So it's pretty interesting. So that's kind of some of the things we're doing. The COOP that the cloud providers are working on and all these different aspects. So making it easier for you, whether it's bare metal, virtualization, VMware, Edge, all of those things. So that's the end. I'll stay around if you have any questions, but appreciate your time this morning. Any questions? All right. Thanks a lot. Enjoy the show. Thank you.